Let's complement part 1 of this lesson 2.1 with some other examples that, even though they look more complex, more complicated, they are still like terms, and we can still do the same process we've been doing. Like in this case, it seems more complicated, it seems more confusing because we have x's and y's, but every single term on this expression have an x and have a y, and more importantly, they all have an x to the power of 1 and a y to the power of 1. So since they all have the same variables with the same powers, this makes them like terms. So it doesn't matter the number of letters they have, as long as all the letters are the same and have the same powers, they are like terms. We could have all the x's squared and the y's to the power of 1, but as long as all the x's have the same power and all the y's have the same power, they are like terms. So we can do the process we've been learning. We copy and merge the variables, the x and the y, and we combine the coefficients, which is 8 minus 4 minus 9, and this is equal to negative 5. So to simplify this expression of 8xy minus 4xy minus 9xy, we can simply turn it into negative 5xy. Let's look at another example. In this case, we have radical 2x, especially in those problems where they ask us to give the answer as an exact answer. We need to learn how to work with this type of radicals. An exact answer means we cannot use decimals. And radical 2, if we put it in the calculator, that's an irrational number with infinite amount of decimals. So we cannot use the calculator for this answer, but we can combine like terms because every single term is radical 2x. So as long as the terms have the same variables with the same powers, or the same radicals, or the same fractions as well, we can combine like terms. So every single time that they share the same radicals with the same variables, we can combine like terms. So since they are like terms, we can copy and merge the variable with the radical 2, and then combine the coefficients. 8 minus 4 minus 9 is negative 5. So 8 radical 2x minus 4 radical 2x minus 9 radical 2x can be simplified to minus 5 radical 2x. Now let's look at this example. Both have y's to the power of 1, which is good, but the left term has an x to the power of 2 and the right term has an x to the power of 1. Since the powers do not agree, are not the same, even though they agree for the y, even though we do have the same powers for the y, the fact that they do not agree with the x's, it makes them doesn't make them like terms. So every single variable and the powers must be the same. Since these are not like terms, we cannot combine them. We leave them as they are. We'll keep practicing this addition and subtraction of like terms as we get further and further in algebra, and you can always come back to this video to remember the process. But now let's do it in a more complex expression. This time we have different type of variables and exponents and terms. Well, all we have to do to simplify an expression like this is we first identify the like terms. The 5x and the 7x, the 2x squared and the negative 6x squared, and the negative 8 and the positive 17. So as long as they have the same variable with the same power, they are like terms. After we identify them, what do? We combine only the like terms. So let's start with the x's to the power of 2, 2x squared and negative 6x squared. We know that all we have to do is combine the numbers. So 2 minus 6 is negative 4. So we get it as negative 4x squared. Then it's the term for the x's. So 5x plus 7x, 12x. And finally, the constants, negative 8 and positive 17, which is positive 9. And this is the simplified version of our fraction. So when we have different types of terms in expressions, all we have to do is combine only the like terms with like terms. And this is how we can simplify equations. Sorry, this is how we can simplify equations. And we will be doing this process a lot in this course and all the further courses, even more advanced math.